We're now going to look at how to use multiple sensors or channels connected in parallel using StarLab. We double-click on the StarLab icon to open the application. And this time we're going to select both sensors that are connected to the pulsar. We can do that either by clicking on each box individually or by selecting pulsar. All the sensors that are connected to the pulsar are selected automatically. We're going to use together, which means that the time axis will be common for all channels. And now we're in the main measurement screen. We now see that there are two channels instead of only one. Each channel is represented by a different color. The numerical readout window shows us the real time, in this case power, being measured by the active channel. Channel A is a thermal sensor measuring power. Channel B is a pyroelectric sensor measuring, in this case, energy per pulse. We select the first channel, which, as we just said, is the thermal, and we can adjust the axes of the graphical readout to appropriate levels to be able to comfortably see that channel. We adjust that to a value that allows us to easily see the information either by using the slide switch or by manually typing in a number. We will again bring the time axis down to a level that's more comfortable for our present purposes. In this case, 1 minute for a full screen. If we select split, each channel is now shown in a separate window. The time axis is still common to both windows, but the y-axis, energy or power, is not common and can be adjusted separately. When we select merge, they come back together into one window again. In addition to measuring, displaying, and logging data from multiple channels, including the basic functions for optimizing the measurements, StarLab enables you to perform various mathematical functions involving the different channels, such as ratio of one channel to another, or even user-defined functions. We do this as follows. We can also add a user-defined function. We call this a math channel. We're now going to see how that's used. We click on Add Math Channel, and we now create a third channel which will be displayed just as if it were another channel, such as the two sensors are each forming. These math channels, we can create any number of them. Their letters begin with M, subsequent channels would be named N, O, etc. The default function that comes up is the ratio of A over B. We can change that to pretty much anything we need. We can also create our own channel by manually typing in pretty much anything that we're required to do depending on what our application needs. If we X that out, then it disappears and we're back to just the two sensors that we started off with. We can perform logging of multiple channels, including a math channel if we have one open. The logging is done in the same way. We would use the log settings window to set up the parameters of the log and set the location at which the file will be recorded. And then we perform the log in the same way as before. We click on Start. The logging is in progress and we can follow the progress on the progress window. We can stop it early if we choose to. And we would open the file. And here we can see two different channels displayed on the logged data. And if we were to open that as text, we would see that as two separate columns of information, each with their timestamps. Here we see channel A and channel B, each with the appropriate timestamp. And the various channels are synchronized with each other in terms of the timestamp so that the user can know which data point corresponds to which data point among the various channels. We can save an overall measurement configuration before we leave the application so that it comes up as a default next time we open the application by choosing Options, Preferences, and Open Last Configuration. Now, when we close the application and reopen it, it'll skip the Select Devices window and go directly to the configuration that we set already as the default.